Welcome to our talk, the Registry Rundown. My name is Cedric from Bockhaven. And I'm a red teamer and offensive developer at Outflank, just like my colleague Max. And in general, we just spend our days hacking away at things. We're both very technical people and also at home with home automations and stuff like that, like my partner says. But he usually thinks I break stuff rather than also repairing them. So Max, you want to introduce yourself?
Yeah, so my microphone's not working, or is it? Oh, great, lovely. So I'm Max, I'm also a red teamer and offensive developer at Outflank. Nowadays we're part of Fortra. And I have more of a software engineering background. So before I went into cybersecurity, I worked more on building websites, building applications for companies, and I took that experience into the offensive world. And in my free time, I also like to do some hardware hacking. I built some conference badges and also do some home automation.
Yeah. So actually, for me, the first conference I ever went to was Hack in the Box. So it's actually great to see now OrangeCon being organized also by a lot of the same people that we knew from back then. And this research was also developed actually at a conference. So 2 years ago, we were at Brucon, and we were just having a moment of, just sitting down and start to play with some scripts, and then we found some interesting stuff in the Windows registry, so that's what we're going to talk to you about today. So a lot of people know that using the registry as an administrator, you can connect to a remote system and just operate the registry. But today we'll see that also as a non-administrator, you can do some quite interesting things with the registry. So our agenda for today is going over some quick history, then look at how the registry can be managed remotely, and then also look at some vulnerabilities and exploitation primitives that might be useful in security work. Starting with some history. So the registry dates back from a long, long time ago, basically around the time I was born. So back in Windows 3.1, the registry was first created for storing COM-based component configuration data. And then also a lot of information was still being stored in ini files. So if you had a program installed, then that program would store its settings also in ini files. Nowadays, or around Windows 95 and NT, what they started doing is moving that information to the registry. So, if you open Registry Editor, what you'll see is a hierarchical view of typically these hives, HK local machine, HK users, and so on. Thank you. And you also have a number of other hives that you don't typically see in the registry, but they are present. So you can interact with them if you know how to. And those are the ones that are grayed out on this slide. There are two hives that are particularly interesting for us, which is, first of all, the HK local machine hive, which stores also all sorts of computer-specific settings, configuration data. So think about local policies, group policies that are being applied on the computer level. So not on the user level, but computer level. In contrast to HK users, which contains then, of course, the user-specific information. Under HK users, what you'll typically see is a number of subkeys denoted by S15 and so on. So S1521 is a domain identifier or local computer identifier. So for every user on the system, you will see a subkey here and storing the information of the individual user. What's interesting here is that there are a number of keys. You see it with the blocked icon that we cannot access. So as a non-administrator, typically you cannot access information of another user. However, if you're an administrator, you should be able to. But what you also see is that there's one hive that we can access, S1518 or the .default hive. You can access that also without administrator permissions on the local system and the remote system, and see what's in there. So S1518 is actually the key related to the local system user, so containing system configuration information, and also stored for example, if you're on the logon screen, like numlock settings, for example, that's what you typically will find in there. And there's a number of other ones, S1519 for local service, S1520 for network service, and so on. So just used for storing user data. Then we have a number of other hives, like HKey classes root, HKey current user. And these are a bit more interesting in the sense that they're not actually real hives. Rather, they are sort of symbolic links or virtual mappings to the real data. So only HK local machine and HK user are actually disk-backed. And if we look at HK user, HK current user, then this is actually containing, again, the information of a specific user, in this case, the user that is logged in, so our own information. And yeah, typically, if you open an application under your own user, then that application might store its configuration data there. Settings are stored here, but also COM classes. We'll get back to that in a second. Then we have HKCR, or HK classes root, and this is where we'll find all sorts of information related to mappings of extensions, like what program should open a doc file or what program should open an exe file. And we'll also find COM class registrations here. Now, HKCR is special in the sense that when you open HK classes root, it will show you information for your own user, overlaid on top of the information that is normally being used for the local system. So it's a special overlaid hive. What is COM then? Already mentioned COM classes a few times. So COM is used on a system as a framework for applications to communicate with one another. Actually, components on the system can interact with one another. So it can be used between processes, but even also over the network if we're talking about distributed COM or DCOM. Maybe you've used this in Microsoft Word, for example. You can do really crazy stuff like embedding an Excel document in your Word document in a PowerPoint document, which is also known as OLE, Object Linking and Embedding, which leans on component object model. And what you can do is, for example, create an object of the Internet Explorer.application class, and then navigate to a specific URL, and that works then via COM. With this class, Internet Explorer.application, there's an associated CLS ID, and that information is stored in the registry under the HKCR hive. And then it will tell, under specific registry key, local server 32, which application to actually instantiate, to run, and interact with on a COM level. All sorts of applications will register these COM classes, so you can then use those COM classes to interact with them. Also a source of many vulnerabilities. If you weren't in this talk today, you would be in Tijmen Gommer's talk, who's also talking about COM and UAC bypasses. HK classes root, for example, if you install Java, they install, 500 of these registry keys looking like a cafe. I don't know why, but I thought it was funny. Max, remote?
Yep. So, as attackers, we want to interface with this registry, for example, to do reconnaissance, to do lateral movement, or maybe even some relaying attacks. And there's at least two ways that we know of on how to remotely interact with this registry. The first method is via the Remote Registry Protocol, or MSRRP. This is handled by the Remote Registry Service, and by default on servers this is marked as auto start, and unfortunately on clients it's disabled. So this protocol we mostly focus on servers. So auto start means that it's not running by default, but we can trigger to run it. So we can access a named pipe and then it will start up and then we can start interacting with it, and then after a while it will shut down by itself again. So how do we do this? If the service is not started, we can retrieve the WinReg file from the IPC $share on the remote system, and this will trigger the service to start. And then we can start interacting with it, and we do this with RPC calls, which are transported over an SMB named pipe, and this named pipe is pipe/winreg. And the nice thing about this protocol is that you don't need to be a local administrator on the remote machine. So essentially any domain user in your domain can go to a server and talk to the remote registry over it. You can actually do this in regedit. In regedit there's a context menu where you connect to a remote server. Or you can use other tools such as reg.py, which is part of the Python Impact Toolkit. And this is actually a nicely documented protocol by Microsoft. There's this huge PDF that you can download with all the different opnyms, all the different RPC functions that you can call. And then you can do stuff like deleting keys, enumerating keys, opening them, saving to them, whatever you want. Now I mentioned that there's a second one, and this one works via WMI. So WMI uses DCOM to communicate, and this in turn again, goes over RPC, but this is like more the traditional RPC that uses a dynamic and random high TCP port. And if you want to interface with WMI, you need to go to the correct namespace, which in this case is root simv2. And then within there, there's a class, the STD regprof class. And this class will have all these methods as well, where you can open a key, read from it, save to it, whatever you want, basically. And there's advantages and disadvantages to this way of communicating. So the advantage is that it's both enabled on clients and on servers by default. But you need to be a local admin on the remote machine and able to be able to talk to it. And you can use PowerShell with getWMI project to talk to it. You can also use WMI Explorer, which is a nice toolkit where you can see all the namespaces, select the right class, and then it shows you all the parameters that you need. And there wasn't a tool available for InPacket yet, so we wrote a little extension for InPacket that communicates with the registry over WMI. And here you can see as well, if you use a regular user, you won't be able to access it. You get an access denied, but with an admin user, you can just list the keys and work your way up from there. So now that we know how to interact with it, let's see how we can actually, as attackers, abuse this. And there's already, of course, some common attack vectors out there. You can do some credential dumping. So you can dump the SAM security and system hives remotely via secretsdump.py. This works via the remote registry. You can also use Mimikatz to do that. Or you can configure persistency to add something to the run key on the remote system. You can do COM hijacks. It's probably Time is talking about right now. And many, many more things that you can do. But there's actually quite some interesting reconnaissance that you can do as an attacker as well. So if we look at what kind of permissions we have remotely, is that we cannot read HKLM if we are a domain user and access it remotely. You need to be a local admin for that, even if you use the remote registry protocol. And if you're a local admin, the HKLM hive has some interesting information you can read about, either which EDR software is installed, the AV inclusions that are configured, local or group policies like Cedric mentioned. So it is quite an interesting source of information. So if you are admin in an operation, this is a good start for reconnaissance. But here we are more interested in what can you access as a domain user. So as I said, you cannot read HKLM, but you can read HKU and HKCR, so the user hive and the classes root hive. If you are logging in, under HKU, you always have access to the .default, the S1518, and if the user remotely is logged in interactively on that computer and you from a remote part log into the remote registry, you can actually also go into the SID of that particular user and view all the settings that are mounted under that key. And then there is the HKCU, which is not the user but current user, and this is nothing more than a symlink. So when the user is not logged in on the remote machine, it will link to .default. And if it is logged in, it will actually map back to that user SID that you can also see in HKU. And this .default that you can always access already has quite some interesting information for you as an attacker that you can use in a reconnaissance phase. But first, let's look at the HKU itself. So here you can see at the bottom that I'm using ref.py again. I'm a regular user and I'm querying the user hive. And here I can see that these user SIDs are actually mounted. So from this information, I can already know that these users are logged in on the remote system interactively, and that I can use in my red team to potentially go to there and then dump their credentials. So this is a nice way to map which users are already logged in currently on the machine. But this is not necessarily new. This is also how the POS logged on tool, which is part of sysinternals, works, and how Bloodhound collects some of his information. But here you can see that if the user is logged in, it will actually be mounted and you can read from it if you have the right permissions. And if the user is not logged in, the whole hive will not be loaded. But what we found is that in the .default key that everybody can access, there's actually also a log of users that historically ever at some time logged in. So if the user once logged into this machine, there will be a record there with the UTC timestamp of the first login. It will not show you if it's currently logged in, but at least you get a sense of what users did ever logged into this machine before. Now, I told you that you cannot access the HKLM as a local admin. But of course, Microsoft wouldn't be Microsoft if there aren't exceptions. So there's actually two keys that configure these exceptions. It's the allowed exact paths and the allowed paths. And the difference between the two is that with the allowed paths, you can actually also enumerate the subkeys. And this is what I extracted from a Windows server. And I highlighted some paths that I'm going to show you later. But if the path is configured in this key, you can actually also, as a regular domain user, access these. So let's give an example of that. Here I'm querying HKLM software, Microsoft Windows NT current version as a regular user, and I get all sorts of information about the system, what kind of architecture is it running, which server version is it, and if it's not a volume license key, even the license key is already there, and you can just access that remotely as a user. But this gives you a sense of, okay, is this a somewhat older system or not, and what kind of ETW rules would that have by default, etc. There used to be a vulnerability in this, which is fixed in October 2022. And we actually sort of found this vulnerability at the same time. It's just that the other person was a bit faster with reporting it than we were. But if you had an exact registry path handle, you were actually allowed to also enumerate the descended subkeys of the allowed exact paths. This was reported and fixed, so it doesn't work anymore. But let's see. Some more examples. So here, as a regular user, I'm also querying HKLM, and I can see what services are installed. And in this case, I can see that CrowdStrike is there because it's configured as an event log service. So now I know that, okay, maybe I shouldn't send an exe to that computer, but use a more sophisticated payload. Huh?
Oh, yes. We still want the system to keep working afterwards. So.
You can enumerate printer drivers that are installed remotely, and then if it's an older system, maybe use Print Nightmare or some other exploit that revolves around drivers. Maybe there's a vulnerable driver on the remote system that involves turning on the RGBs on your memory stick, and that has a vulnerability. And at least now we know what drivers are there that we can potentially use at a later stage. And querying all these registry keys is generally not considered as malicious, so you will not run into any detections unless there's like very specific trapdoors in there, so to say. So this is a nice way to do some remote reconnaissance, and I'll give one last example. This is the classes root, which you can fully enumerate as a domain user, and here you can see things like, okay, the open with list, like what kind of files have been opened in the past and how are they configured, and in this case we know, okay, there's at least Word and Excel on there, so maybe we can do something with that. And now we go into a few vulnerabilities that we found. We found two vulnerabilities that are around information disclosure. We reported them to Microsoft. They came back to us that they said they were not critical, not high impact, but they still sent them to their respective teams to be fixed. The first one is that as a regular domain user, it's not possible to read HKLM keys, right? Without these exceptions that I just mentioned. But if you use the remote registry protocol, the RPC responses that you have on specific calls actually leak some information. In this case, it leaks information about the existence of the HKLM key. So what we do, we first open a handle to a specific subkey in HKLM that we want to check out. And we set the sum desired to key set value, and I'll show you in a bit why we do that. This should result in an access denied, because we do this as a regular domain user. And then we try to delete this key. And once we delete this key, there's actually a leak in the information in the response code that will tell us if the key exists or not. So I have it visually here. First we open the key. And here we should get an access denied because we're a regular domain user, right? And if we do not get an access denied, we should actually abort, because then otherwise it would mean that the next step we're going to delete the key. We're actually going to delete the key on a remote system. And generally you don't want to do that on a production system. So this is like a safety check in there. Then we try to delete the key, and then we can see what our status is. And there's basically two. You can get an error file not found, and that means that the key doesn't exist. Or you get an access denied, and then you know, oh, the key actually did exist. I just don't have access to delete it. And we made a little script that feeds a file, gets fed in with all the different keys. And now you can enumerate and see what kind of software is installed there. So you can give it a predefined list of some EDRs and some other software, and then we can remotely see if it exists or not. There's a second one, and this basically allows you to check if a random file exists on the remote file system or not. So here again, we open the key first, but we now use HKU, and HKU every domain user can do. And then we try to save this key remotely on the file system on a specific path. And this response code actually reveals if the file exists or not. So again, visually, we open the key, we're allowed because it's HKU, we try to save it, and the return status tells us either the directory does not exist or the directory exists. And this you can then also use to see if certain files or programs are installed on the remote system, which is a nice reconnaissance thing to do. One more thing from my side before I hand it over back to Cedric. In the past few years, we actually abused ADCS quite a lot. And for those who don't know what ADCS is a role that you can install on your domain controller. And it's basically Microsoft's PKI implementation that hands out certificates based on templates. So it can be a certificate for Kerberos authentication or for authenticating to your Wi-Fi or whatever you want with that certificate. And it turns out that these templates are generally quite easy to misconfigure. And in certain combinations, we as attackers can abuse those to get domain admin, basically. And normally we would query these certificate templates via Certify or Certify, and they use COM or RPC or LDAP to query towards the domain controller like, hey, can you give me all the certificate templates that are configured in this environment? But since this has been abused so much, there's actually quite a lot of detections around this as well. But it turns out that by default, every domain joined computer that is part of the domain where the ADCS is configured will have a local cache of all the certificate templates in its registry, in the default key, which every domain user in the network can query. Which is great for us because we wrote a little tool which we call Registry, where you, and here I use regedit, but you can also do this remotely. You export this whole subtree, and then we feed it into our tool called Registry, and then you get an overview of the certificate template. And I'll explain why this is vulnerable. Every user you can see at 3 that every user is allowed to use this certificate template to request a certificate. You can use it for client authentication, so it means you can use it for Kerberos, and the one that enrolls the certificate, so us, the domain user, can define for who the certificate is. So we can fill in, we are domain admin Pietje, we want this for Kerberos, we are domain user, we can request it, and then within 2 steps we are domain admin. Really nice way to use in a red team, and really nice to get the certificate templates this way.
Yeah. So a lot of reconnaissance possibilities, and again, I want to stress that you can do a lot of this without administrator permissions. So accessing this sort of information is normally not possible without having administrator rights. So we'll see in the next few slides also how we can abuse that for malicious purposes. Starting with relaying. So there is a registry RRP interface you can use, basereg save key, to trigger a coerced authentication on the remote side. So for people familiar with Petit Potam and similar coerced authentications, this is a variation on that. Just need to call it with a few specific parameters, and then it will tell you error privilege not held, and in the meantime you receive the hash of the remote computer, which you can then use to forward it, for example, to ADCS and obtain a certificate for that computer system. Next to saying error privilege not held, it will actually create a file on the remote system where you pointed it to and create it, but it won't have any content unless you are administrator. So one funny thing you can do with that is, for example, you can course a domain controller and have a file put there in the temp folder, making it look like the system is being cryptologged, if you want to cause mayhem. But yeah, I think the most interesting one for us is lateral movement. So as a non-administrator user with the remote registry, you can laterally move, which is normally not possible due to remote UAC controls. So first, let's have a look at how this works as an administrator. Normally, if you want to execute code as an administrator, what you would do via the registry is perform some sort of a COM hijack. So modify a CLS ID under the HK local machine and then find a way for that COM object to be triggered. This does not always work because you need trusted installer permissions in a lot of cases. But for some reason, if you create software Microsoft app model look aside, if you create that key, the registry will also look in this other location to see if there's an entry under it. We don't know why, but it does not require trusted installer permissions. So just if you do this remotely, you will be allowed to, and then you can perform a COM hijack. So in this case, you still need to find a suitable COM object to hijack and then wait until it is instantiated, or you need to find a way to trigger it. Another option for triggering it is finding a service that also instantiates a COM object and then triggering that service remotely. Coincidentally, it happens to be the case that using RPC calls, you can trigger about 50 services remotely to start, including services on the domain controller. So we have a small demo of that here. You can send an RPC ping to those services, and then 1 second later it says triggered, and then the service actually started on domain controller. And you can do this with a lot of services, and a lot of those services also instantiate their own COM objects, which you can hijack and then obtain remote code execution. Then, as a not administrator, what we can do is modify information under HKCU remotely. We've already seen that in Max's slides, and we can do the same trick. So perform a COM hijack under the current user, and if that user then opens the application that uses the COM object, it will trigger, and you get code execution. Because also for classes stored under the HK classes root, HKCU takes precedence, so this is the way we can do a COM hijack. But which COM object are you going to target? You could target Microsoft Word, for example. So if the user opens Microsoft Word, it triggers. But if you want to have a little bit more control over when it happens, if you want to have a good target, one thing to do is, for example, find handles to keys with notify access. So this is a screenshot of System Informer showing which registry keys are currently opened and which have notify access, which means that if something happens to the key, the application that uses the handle will do something with it. So what we see here is that searchhost.exe, for example, the one highlighted, has notify permissions. So if you modify that key specifically, it will trigger something in searchhost.exe. So what we did is basically the same thing. We modified a key under this path, just inserted some garbage, and then we didn't know exactly how to change it, so we just let the process crash, which starts webfall.exe, which is the error reporting service, which has its own COM object, so we can perform a COM hijack on that application instead. Small demo of that, regexec, and it's set, and then once we switch back to the computer view, we now have a calculator running. One last thing then is we noticed the same thing with Citrix. Citrix has an interesting setup where a lot of cases they allow all domain users to RDP to a system, but then perform access control once you are logged in. So really, after you've already gotten permission to log in, they perform access control. So this is what you see when you log in via RDP, saying you don't have access. But this is actually running under the context of the user that is already logged in. So what we can do is perform a COM hijack via the registry remotely, and just click OK on the screen, and then we get access. We also reported this to Citrix. They thought it was not a vulnerability, but you may convince us otherwise. Yeah. So yeah, in summary, a few ways to abuse the registry remotely for reconnaissance, relaying, and lateral movement purposes. If you want to know more, there's some great research being done recently by Google Project Zero, Yoru, who has gone from Windows Registry in literally 1992 up until now. I don't know how he found out the details. He must have got some contacts within Microsoft. Really good resource, as well as Pavel Josipovic blog posts. Thanks a lot for listening to us.